I'm using my school's Tektronix TDS 3032C oscilloscope to automatically generate Bode plots. I can automate the process on my computer by using the scope's Ethernet port in the back. This uses advanced channel settings, acquisition modes, triggering, and a message box that I can display to show the current status. I connect my scope to my campus network by going to the utility menu, and one of the options under System I/O is I/O. Then I can go to Ethernet network settings, turn on DHCP, and find my scope's IP address from here. By putting the scope's IP address into your web browser's URL bar, you can visit the scope's web server. From here you can see a screen capture of the oscilloscope and control how often it refreshes. In the Data tab, you can select the waveform to be captured, and you can download a spreadsheet of the current waveform on the scope. You can also send commands and receive a response back. The commands you can send are published by Tektronix in the programmer manual. There are other tabs in here, and from the Control tab you can actually send front panel push buttons to the scope. Here's the software control behind the Bode plotter. It accepts the scope IP address, the input channel, output channel, and a list of frequencies. The first step is to turn on both channels. The next step is to set up the three measurements. Now I want to measure the input amplitude, the output amplitude, and the phase difference. Then I do an auto set on the scope to make sure that both signals can be read by the scope. Next, I center the channels vertically and band limit both of them to 20 MHz. Then I set the acquiring mode to 8 averages. Then I enter this loop where I iterate through the frequencies that the user gives me, and for each frequency I play it out of my sound card, and then I set the trigger hold so that I'm just triggering on half of a period. Then I set the time per division to try to show about 3 periods on the scope. Then I set my voltage per division to fill about 9 divisions. Then I read in the amplitude and phase, and when I've gone through all the frequencies, then I return the magnitude and phase to the user. The system under test is a 4th order bandpass filter using a Salient key topology. The input on channel 1 is connected to the waveform generator, and the input signal comes from the headphone jack of my computer. Channel 2 is on the output. For this test, I'm going to put in 25 Hz to 18,500 Hz on the log scale, and then just tell my Bode plotter function to begin testing. During the test, you can see that there is a progress bar that shows the current frequency being tested, as well as the percent of the completion of the test. The horizontal scale is automatically adjusted to fit the right number of periods onto the screen, and the vertical scale is always adjusted so that the waveforms are exactly the same height. On the side of the screen you can see the 3 measurements that are being taken and being saved to MATLAB to create the Bode plot. Here I compare the theoretical response of my bandpass filter on the left with my measured response on the right, the oscilloscope. There's very close agreement between the two. And this test took about 25 hours to run with 10,000 different data points. Fortunately, I didn't have to be there for any of it because it's all completely automated.